That's right. My literal 10 ones of subscribers will.
13 now.
Is it 13?
I'll go subscribe.
I gotta start like putting ads up and make some money.
Like this link to like and subscribe. Like
Get that check from YouTube every year for 1 cent.
get like an overlay and everything. Like that's what I was like. Don't forget to like.
Like, I gotta pay taxes on it though, so
you should get ads.
rounds up unless I get 0 cents.
No. The way YouTube works, you'd have an ad every like 15 minutes.
Exactly.
4 ads. Like
Please hold. My already long notes would be even longer. All right, so here we go. We're going to talk about infinite limits today. Infinite limits. Okay, so consider. And you may want to have your graphing calculators handy just so we can like kind of analyze things as well. So if you don't have those out. Yes, sir.
Can I borrow a graphing calculator? My sister stole mine again.
If you want to borrow that one, yep. The yellow one there. Yellow. Actually, let me keep the yellow one. I'll get you one. Put that right down there. Okay, so this function should be familiar to us, right? It is a transformed version of one of our family of functions that we should know, right? So this is a transformation of what standard function that we have?
It is the transformation of a rational function.
A rational function 1 over x, right? It's a transformation of 1 over x. Specifically, what is x minus 2 going to do?
Give it an asymptote.
Okay, it shifts it what direction though? The original 1 over x. To the right, 2, or to the right for you guys 2. That's right. So let's sketch this. Let's sketch a graph. Okay, so we should have an asymptote then at 2. And since it doesn't shift up or down, we can assume then it's just going to kind of do something like that. And something like that. Okay, and that's our function f of x. Question. So what do you think that 3 does? What does it do when we have kind of like a 3 out front of our function, or we multiply our function by 3? What does that kind of do?
It's the general period.
It stretches it some, right? Stretches or compresses it depending on the number. So in this case, a stretched version of that emma is still going to look pretty much the same as a non-stretched version. So if it was like sine or cosine with a 3 in front of it, obviously the amplitude would change, and we would really take that into account. For something like this, it doesn't really matter, okay? And so we can actually confirm that on our graphing calculators here too. It's not going to be too crazy. You see, the 3 doesn't really show up that much, okay? I'm sure if we made it a larger number, it might show up more pronounced, but there it is. Okay, so we're going to continue our examination of limits from one-sided limits, right? So, for example, let's consider the limit as x approaches 2 from the left of 3 over x minus 2. Okay. What could we say here is our limit? What is our limit as x approaches 2 from the left? Negative infinity. Okay, how'd you know it was negative infinity? Right, it goes, so we're going, as we approach, here's our asymptote right here at 2. We're approaching 2 from the left, so there's our function. We're approaching our value 2 from the left, and it goes down, like way down to negative infinity. Okay, now, the correct, or that answer is correct, but the best answer to put here is, what do we say about our limit? Does not exist, right? Okay, so really, ultimately, our answer is D and E, or does not exist. Okay, yes, it's not bad to recognize that it goes to negative infinity, but ultimately, the more complete answer is does not exist. Limit does not exist. Okay, let's try another one here. What about the limit as x approaches 2 from the right of 3 over x minus 2? Okay, so now we're approaching 2 from the right, so just anybody, what's it going to be? Positive infinity, or just infinity if you want to say, yes. And again, though, the correct answer, not the correct answer, but the more like precise answer we should say is what? The limit does not exist. Okay? Again, the concept of a limit The concept of a limit is that it has like a stopping point. When you have a limit, that means it does not go any further. But if you try to say that infinity is a limit, infinity goes on forever, right? So that doesn't make sense to call it
If you were to just
a limit.
like negative or positive infinity on the AC test, would they kind of
So it depends. Sometimes they will ask for like, you know, which specific direction does it kind of go. So they might ask for something like this, but you know, ultimately recognize that that means it does not exist. So I think as long as you make that kind of clear, you can like show basically, and you can show this kind of analysis, and then just say, okay, that means it doesn't exist. That should cover both your bases. You've shown which exact infinity it goes to, and that it does not exist. So you cover your bases. Okay. So a limit in which f of x increases, okay, or decreases without bound as x approaches c. So a limit in which f of x increases or decreases without bound as x approaches c is called an infinite limit. It's like, well, duh. Okay. Okay, this is different. This is different than those limits you guys learned about in pre-calculus, or my ABC, you know, kiddos learned about when you took x as x approaches infinity. I'm assuming, did you guys do as x approaches infinity too? Okay, so we'll get to those probably tomorrow. Okay, those are limits to infinity. These are infinite limits. Okay, which is like, that's a subtle difference there, Mr. Moore. I might get that confused. Okay, that's all right. But try not to. All right, we got to get that hashed out. Okay, so what I want us to be able to do here for our first examples, we're just going to determine the limit of each function. I have it. I have the email there. I have my email, so that's okay, Kylie. So yeah, thank you. Determine the limit of each function f as x approaches 1 from the left/right. Okay, so that's what we're going to do. We're going to determine the limit of each function f as x approaches 1 from the left and right. Okay. We're going to do quite a few here, so let's see. Okay, so let's see. F of x equals 1 over x minus 1. So there's our first function, and that means we want to take the limit as x approaches 1 from the left, and the limit as x approaches 1 from the right. Okay. And so we can go to our graphing calculators for this, right? That's one tool that we have available to us. So let's go ahead and graph that, 1 over x minus 1. Okay. And again, those of you that, you know, need to practice these graphing calculators, please follow along, okay? I know it seems like silly. It's like, Mr. Wood, really, when you punch these buttons, you just have it up there on your screen. Well, I want to make sure you graph it correctly, okay? There's an easy way. So, for example, I don't know, let's see. Do I want to try and trick people here? So it's like, did anybody get a graph that looks like that? Okay, good. You better not have, because that means you forgot to put parentheses around your denominator. Okay, that's what it should look like. That's right.
It's slippery, Mr. Whitmore.
Well, I just want to make sure we're graphing things correctly. It's easy to miss things. Okay, so as we approach 1 from the left, okay, as we approach 1 from the left, Joey, what is our limit going to be? Good, yeah, negative infinity, which really means, though, it does not exist. Okay? And let's see here, Josh. How about as we approach 1 from the right? What's going to be the limit? What do we approach there? As we approach 1 in the graph here, here's 1 right there, right? As we approach 1 from the right, what do you see there? Well, so there's 1, but the function is right here, right? This is the curve. So as we approach 1 on the curve, we're getting closer and closer to 1, but then what happens to our curve? It goes up there. So it goes to what? What's our y value approaching there? Yeah, infinity, a positive infinity. And so again, we'll say the limit does not exist. Okay? So there it is. Okay, so why don't you guys go ahead then do the same kind of analysis for these next 3 I'm going to give you. So next one will be 1 over the quantity, x minus 1 squared, x minus 1 squared. Okay, and then also try it for negative 1 over x minus 1, and then do it also for negative 1 over quantity x minus 1 squared. Okay, so again, determine the limit of each function f as x approaches 1 from the left and the right, and you may use your graphing calculators to help you with that. Yep, still approaching 1. Yeah, the directions are true for all of these. All of them are going to be approaching 1, from the left and from the right.
I'll come back to those quizzes.
That was hard. Really struggled there. Yeah, I have a time with
Oh, right. I gave you a practice copy. I like that as well. Second copy of the practice test. Second copy of the test, I should say. I like that back as well. Oh. Very good. Thank you. Do you have your original still?
I do.
What is that?
Oh, it's the free test?
Yeah, boy.
I didn't do that.
The test. What do you need back now, Mr. Wiz? Oh, you don't, I have yours.
Okay.
If you didn't retake the test, I still have your old test. So, you have to practice, I can give you a copy of the practice test.
You gave it to me, but I couldn't find it anywhere.
Okay.
I don't have like the practice stuff though, like the original.
You like this thing?
That was out anywhere.
Yeah, I like that.
I think we got this parallel. I thought it was perpendicular. I did look at it.
Yeah.
Like,
Be careful.
Got to be careful.
You have your all the tests. Sit down with, and then you do a copy of the practice test too, that test too now. So you have your old test. Yellow cover. No. We should.
early.
I was gonna say, I can remember if it was the people.
No, someone else wasn't saying it.
I think there was some people that did, did not reply.
So.
Oh, yeah, okay.
Oh, I can do a better one.
Okay, let's go over this. Here we go. Okay. Ugh. Okay, so Christian, how about for B here? Limited x approaches 1 from the left.
That approaches infinity.
Positive infinity, which really then means does not exist. Okay, how about the one from the right?
Said the same thing.
Same thing, so does not exist. Good, thank you. All right, how about Drew, letter C? 1 from the left? Positive infinity, so therefore really does not exist. Okay. Negative infinity, so really then, yeah, does not exist. Okay. And then let's go to Donovan, 1 from the left. Say it one more time, I'm sorry.
If we can see in the graph that it doesn't exist,
Yeah, you can put does not exist. I was interested also in what specific infinity it was approaching. So it's approaching positive or negative is what I guess I'm interested in. Yeah, exactly right. They both will approach negative infinity. And so both do not exist. What I'm trying to show here is that you can have pretty much every option. Here, the left approaches negative, the right approaches positive. Here, both approach positive. Here, for letter D, both approach negative. And then here, it alternates to left side's positive, right side's negative. So just understand that you can have any sort of those combinations. That's why you need to really make sure you analyze both sides, okay? Just because one goes to negative infinity doesn't mean the other side has to go to positive infinity, or vice versa, okay? They can both go to positive infinity, they can both go to negative infinity, depending on how your function is. So please make sure you consider that.
When it passes the quiz, you see that it doesn't have specifically to see the one from the right, and you know one goes to infinity, or can we just say it does not exist?
If you know the limit goes to infinity, then just say it does not exist. That's right. And the homework directions, I think it'll say specify kind of which infinity it goes to. I think for the homework. Okay, just I don't know, just so you know the shape of the graph. Kind of is the idea. All right. So determining infinite limits. So what if though we don't have our graphing calculators?
Ooh, I did that.
Right? Just give up. Abandon ship. Well, there you go. So let's examine kind of like a method here to how we can try and do this without a graphing calculator, and just use our brains, which are also kind of graphing calculators, in a sense. Okay.
You can't put block root in your head.
It's harder, yes, for sure. Okay, so right away I'm looking at this, and I'm like, all right, we got like an x here. I'm going to factor out an x in the numerator. Now, that's not to try and cancel it. It's just kind of help with the math that we're going to do. Okay. So, let's try and kind of, mimic what our calculator would do, or what we would do with our calculators, right? In our calculators to do this, we would graph it. Well, that's harder to kind of mimic with our, mentally, but we could also use the table in our graphing calculators, right? And so if we're trying to approach one from the left, what kind of values do we want to attempt to plug into our graphing calculators? 0.9. So if we're approaching positive 1, be careful, we're approaching positive 1 from the left, what kind of value would we want to plug in? 0.9. So let's just try 0.9. We'll hold off on 0.99. So let's just try x equals 0.9. And let's try and analyze this, okay? So if I try x equals 0.9, that means I'm going to plug in, here instead of x, I'll put a 0.9. Here instead of x minus 3, I'll do 0.9 minus 3. And here instead of 0.9 minus 1, I'll do, instead of x minus 1, I'll do 0.9 minus 1, sorry. Okay? All right. Now we're going to do a little bit of fuzzy math here, but again, this is just for analysis sake, not for precision. We're just trying to see, whether it goes to infinity or negative infinity, which infinity it goes to. Okay? So, let's see here. Doing some kind of fuzzy math. 0.9, I'm just going to leave it as about, what is 0.9 about? It's about 1. So I'm going to put like a little squiggly equal sign here to also indicate it's not exactly equal, right? So we'll say that's like about 1. And then 0.9 minus 3, well again, 0.9 we just said was about 1. So 0.9 minus 3 is about 1 minus 3, which is then what? Negative 2, right? Okay. 0.9 minus 1, though, let's be a little more precise here, and let's actually do that, right? Because that's easy to do. What is 0.9 take away 1? Negative 0.1. Okay? So roughly, what will this equal? Well, 1 times negative 2 is negative 2. Divided by negative 0.1, what does that actually end up being? A positive number. In fact, positive what? Positive 20. What does it mean, positive 20? Okay, how do we know that? Let me maybe do this a little bit easier for you. What is 0.1 as a decimal? It's negative 1/10, or sorry, as a fraction, it's negative 1/10. So instead of dividing by negative 1/10, that's the same thing as multiplying times the reciprocal, negative 10 over 1, and so you get positive 20 there. Okay? Now, let's try going even closer. Let's say x equals about 0.99. So that would be 0.99 times 0.99 minus 3 over 0.99 minus 1. Okay? So again, approximately, well again, what is 0.99 in the numerator there? Kind of close to 1. 0.99 take away 3 is even closer to 1 now, so it's going to be even closer to that negative 2 value than we were before. 0.99 minus 1, if we do it precisely, is negative 0.01. Okay? Now, when we divided by negative 0.1 before, that resulted in really multiplying by negative 10. Divided by negative 0.01 is going to result in really multiplying by what? Negative 100. And so this becomes then 200. So what can you see is going to happen as we do add more 9s here? What's going to happen? It's going to go up to like positive infinity. We're adding zeros. Okay? So without having to actually use a calculator here, we kind of convinced ourselves that this limit then is going to go to positive infinity and therefore does not exist. Okay? It's going to keep getting bigger and bigger and bigger as you get closer and closer and closer. Okay?
So is 2 numbers fine to do when you're trying to...
Yeah.
Okay, 2.
Mm-hmm. That's fine. Yep. Okay? And so we can provide that analysis for other things too. So for example, the limit as x approaches 1 from the right of x squared minus 3x over x minus 1. Okay, so it's the same thing, but now we'll approach 1 from the right. Okay. Rather than writing this all out, though, let's just go back. Again, that's going to become the limit as x approaches 1 from the right of x times x minus 3 over x minus 1. But again, rather than writing out all this work over here, let's just kind of do a little imagination stuff, okay? So if we're approaching 1 from the right, that means what kind of x values would we potentially plug in? 1.1 or 1.01? So let's imagine plugging in 1.1. Okay, 1.1 would be, if I plug that in here, it's going to be like 1.1 times 1.1 minus 3 over 1.1 minus 1, right? Okay, so 1.1 is about 1. 1.1 minus 3 is about 1 minus 3, so it's about negative 2. 1.1 minus 1, though, is 0.1, which then is really like multiplying by 10, so we end up with a negative 20. Okay, so now what does it look like we're going to be approaching? Negative infinity, right? Because if we do if we do 0.01 or 1.01, that's going to get to negative 200 and so on and so forth. And so yeah, this goes to negative infinity, which again does not exist, but that's a way you can kind of like analyze that without having to do use a calculator. Okay, kind of just use a little funny math there. Okay. All right, so the properties of infinite limits, let's take a look at that. Okay, we've already talked about the properties of limits, but infinite limits have similar kind of properties. Infinity is just kind of a unique number, I guess. So again, we'll say let C and L be real numbers, and let F and G be functions such that the limit as x approaches C of f of x is infinity, and the limit as x approaches C of g of x is L. Okay. So again, C and L, we're just saying they're real numbers, that's all, just declaring those variables. And of course, F and G, those are our typical, stereotypical kind of like, oh, these are random functions. Okay. In this particular case, the limit as x approaches C of f is infinity, positive infinity. And in this particular case, the limit as x approaches C of g of x is a number. It does have a limit L. Okay. So that's kind of our setup there. All right, so questions so far on that? We're okay? Just on the setup? Okay. So the first thing we're going to look at then is a sum or difference property. Okay, so the sum or difference. So that means the limit then as x approaches C of f of x plus or minus g of x. Okay. What do we want to say that limit will be? If we take f, whose limit is infinity as x approaches C, and we add or subtract g, whose limit is L as x approaches C, what is going to be the overall answer there? If you take something that's infinite and add or subtract a finite or a finite thing, what's going to go to? Infinity still. Right? Infinity overwhelms whatever that number is. Even if L is like 1 trillion, right? Infinity plus a trillion is still infinity. Infinity minus a trillion is still eventually going to go up to infinity anyway. Okay? Again, this is only true if L is... Oh, no, sorry. That's for the next one. My mistake. That's true for in general there. Okay? All right, product. The limit as x approaches C of f of x times g of x. Okay? What do we want to say that will equal? And I'm going to give a little caveat here, if L is greater than 0. So assume that L is greater than 0. If we take something whose limit goes to infinity and multiply it by a positive number, it's going to go to infinity. Infinity times a positive number is still infinity. Okay, likewise, if we take f of x and multiply by g of x, but this time we say L is less than 0. Okay, we say L is less than 0. That means that the limit will be what? Negative infinity. Okay, one more property and then an example, and then we're done. All right, and the example will be quick. I'm sorry, guys, this is really cutting it close, but we can do it. I believe in us. All right, so the limit as x approaches C. For this, for quotient now. Okay. So here we're going to take something whose limit is a number and divide it by something whose limit is infinity. What will that result in? What will that value go to? If you take something that's finite, or finite, I think it's finite, and divide it by a really big number that keeps getting bigger and bigger, what is that going to go to?
0.
So let's just try it. Let's just pick something. Let's say like 5 divided by a ginormous number.
Approach 0.
That's 5 e to the negative 13. That's 0.00000000005, right? So what does it go to? It's not negative number, it's just 5 to, it's like point, it's to the 10 to the negative 13. So what's this going to go to? 0. 0. 0. Okay, it doesn't matter if yeah, it's 0 because you're dividing by a really big number. That big number is, you know, infinity. And then if you flipped it, right, if the infinity was on top, then it would be going to infinity. All right, let's take one quick look at an example here. The limit is x approaches 0 of 1 over 1 plus x squared. Okay. Now you might look at that and say, how the heck am I supposed to do this? It's like two things. How do we evaluate a limit when there's like kind of two separate things in it like that? Well, remember your old limit properties, okay? We can break this up. You can break up a limit over addition. So we can find the limit as x approaches 0 of 1 and add to it the limit as x approaches 0 of 1 over x squared. Okay. What's the limit as x approaches 0 of 1?
1.
This is not a trick question. It's 1. Yeah, it's very, very simple, right? What's the limit as x approaches 0 of 1 over x squared?
Does not exist.
It does not exist. It goes to what? Positive infinity, right? We're talking about really small numbers. We're going to square those really small numbers, making them even smaller, and we're going to divide by a really small number, then makes that number overall very big. So it goes to positive infinity. So then, what is 1 plus infinity really equal, though? Infinity. So therefore, limit does not exist. Okay? So when you get a limit like this, and this is, you know, this is something that maybe will throw some of you off. If you get a limit like this, and it's got addition there, just break up the limit of the addition. Okay? All right, for your homework, it's going to be page... Okay, so count. Page 108, numbers 1 to 9 odd, and 43 to 51 odd, and then I also have a worksheet on continuity as well. And I'm also going to pass out the review sheet to you for the test, so you guys can have that to look at in preparation. Okay? So this is the continuous functions worksheet. See how it says continuous functions at the top? This is the Chapter 2 review sheet. See, it says Chapter 2 review sheet at the top. Okay? So you can start looking at those things and making important decisions about how you're going to study. Remember, this test